Yo, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And yes, we are continuing with our binary search tree data structure topic and we are moving on to the implementation and the practical side. Now before we continue, in case you've missed the previous tutorial, in the previous tutorial of this course of this playlist, we discussed what is a binary search tree, how is it different from a regular binary tree, and how is it better from other linear data structures when it comes to searching and the different operations and the different time complexities. So that video was a complete theoretical as well as a diagrammatic representation. So in case you've missed that, in case you don't know what is a binary search tree, please watch that video first because this is kind of like the part 2 of that topic. And in part 2, as I mentioned, we are now moving on to the implementation and the practical side. When I say practical side, ultimately we want to write a program, right? So along with theory, we also want the practical knowledge. So that is what we are going to cover in this tutorial, and for this tutorial specifically we are going to get started with writing the C++ code. We will type in the treenode class as well as initialize the BST class, and I'll talk about that in a minute. And we'll also discuss the strategy in which we are going to approach this problem, approach this implementation. And lastly, I'm going to divide this entire practical aspect into multiple parts depending upon the different operations like insertion, searching, deletion, because it won't be possible to cover all those things in one video because we also want to understand the code, take a diagrammatic representation, and we also want to write the code, so that becomes hectic. But anyways, without further spending more time, let's start off with today's topic. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks, and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Alright, so on the left hand side you can see a basic diagram of a binary search tree which is implemented as a dynamic nodes in the memory. So what do I mean by dynamic nodes? Now in case if you've watched the tutorial of binary tree, we discussed that there are two ways in which you can implement binary tree data structure. One is using this dynamic node strategy and one is using an array. We've also used this dynamic nodes in the memory strategy for linked list and other data structures previously in this tutorials course. So if you've been following this must be very easy to understand. Basically what we're doing is we're creating a node class, and the node class has a left and right pointer which is of the same type. Now I'm saying pointer because ultimately we're going to write a C++ program. We're going to use C++ programming language. However, if you're using another general purpose programming language, the logic is pretty much going to be the same. However, we do not have pointers in those programming languages. So the strategy and the approach, the syntax might be different. Anyways, coming back to our node class will have two pointers, left and right. And the center value is going to be the actual data, also called as value or also known as key. So when it comes to binary tree and tree data structure, you'll come across these three terms, data, value and key. They're pretty much the same in most cases. Over here I'm calling it data. While writing the code, we will write it as value. Okay, you can also use key. But when we create the node in the memory, in the programming part, let's say this is node N1, it will be created in some memory address. This is that address #10 in brackets. Let's just assume that this is not a real address value. This is the top node, this is the root node, you can see, right? It has the value of 45, and according to the binary search tree principles, everything to the left of this node should have lesser value as the data. So you can see N2, N4 and N5 have 26, 7 and 33, which is less than 45. Similarly, on the right hand side of N1, that is for the right child, we have N3, then we have N6 and N7, whose value is 68, 51 and 75. All of them are greater than 45. So that's how a binary search tree is different from our regular binary tree, which follows the main principle that everything in the left subtree for every node will be less than that node value, and everything in the right subtree will be less than the value of that particular node. So this not only follows for N1, it also follows for N2. For N2, the left child is 7, which is less than 26. For N2, the right child is N5, whose value is 33, which is greater than 26. Okay. So this is something that we've already talked about, and our approach is going to be this structure that we are going to create programmatically. And to create this, of course, the first thing that we'll have to do is we'll have to create this tree node class, right? So let's take a look at how this node class would look like in terms of a pseudocode kind of way. Okay, so on the right hand side, this is where the class is represented or shown, and the class will have some data members which you could understand right from over here only. It would have a int value, so this is going to be this center value. The second data member in this class will be a pointer called left of the same type of the class, right? So the class name is treenode, so the pointer left should also have the same type. I hope you know the concept of pointers. I hope you know the concept of classes and objects. I'm assuming you guys already know the basics of C++ programming language. All these concepts of, classes and objects, dynamic memory allocation, pointers, everything I've covered in a separate C++ tutorials playlist on this channel itself, so you can check that out. But moving on, the third is again a right pointer of the same type. So this star represents that it is a pointer. So 3 data members, and the member functions are nothing but 2 simple constructors. One is default constructor, one is parameterized constructor. We will need them when we create these individual node objects, and then later on we will link them. Now you can see that there is some linking happening. So n1 for the left has the address of hash 23, and hash 23 is the address of n2. So this linking is happening, and this linking will happen in another main class, which is the binary search tree class. Okay, so we will create one more class which is actually going to be the main class, which will have all the different binary search tree functions. When I say binary search tree functions, it would mean insertion, it would mean deletion, it would mean traversal and printing, and it would also mean searching, right? So those are the main standard binary search tree functions which we will have to implement, and which we will implement one by one in further upcoming tutorials. Okay, so now let's see that BST class. Okay, so as you can see on the right hand side, there's a lot to go through, and don't get intimidated. This is not a big deal. We will be tackling everything one by one, part by part, so everything will be easy to understand. So this is our class named as BST. This is the name of the class. Moving on, the data members in this BST class is only going to be one data member, which is going to be the address to the root node. So this treenode star root is nothing but a pointer named root of the type treenode, and treenode is something that we just discussed. Treenode is our own custom class, right? So this root is a pointer of type treenode, so it will only point to objects of treenode. Okay, so that's the only data member we need. However, in the member functions we have quite a lot of things to cover. So the first member function is tree_empty function, which is nothing but a function which will check if there are any nodes attached in the treenode or not. The second is going to be insert node, which will take the address of a node and attach it. So let's say you want to attach a new node over here. The value is 30. So this is going to be to the left of n5, right? And let's say this is n8 with the address of hash 99. So whenever you do the insert, you will take this hash 99 address, which will be passed over here, and you will add it over here. Hash 99 will be added, and this linking will be made. And of course we will discuss each individual function in detail. Right now I'm just giving you an overview. So this was is tree empty. Then we have the insertion done. After that we have different traversal techniques and different printing ways. So you can approach or traverse through this tree in different ways, and the two main categories are the mode in which you traverse the entire tree. When I say mode, it would mean the depth first traversal and breadth first traversal. So again, we will discuss this in detail, but technically in depth first, what you do, you go deeper into the different levels and then you print it. When it comes to breadth first, you print level by level. I hope you know what are levels. So this is the first level, or you can say level 0, where the root node is LVL0. Then on level 1 we have 2 nodes, right? So this is level 1 and this is level 3. So in breadth first approach, what will happen? The values at level 0 will be printed. So 45 will be printed first. Then the values at level 1, what is the values at level 1? 26 and 68. So 26 and 68 will be printed. Then the values at level 2 will be printed, which is 7, 33, 51 and 75, and so on and so forth. So that is what is breadth first approach. And when it comes to depth first, you have multiple ways of traversing. We have pre-order, we have in order, and we have post order. Okay, we will discuss them in detail when we come to the printing part. So I have written in comments print and traverse because in order to print the entire tree, we also need to traverse it, right? So both things happen at the same time. So 3A, B, C and D are nothing but depth first traversal approach, and 3D is a different way to print the entire tree in a 3D way. Again, we will talk about this in detail, don't worry. So A, B, C are the three different ways: pre-order, in-order and post-order. 3D is a special way to print the tree so that you can see a tree visually also. 3E is the way you print the level order or breadth first traversal. Breadth first traversal is also known as level order. So this was entire thing about printing and traversal. Then the point number 4 or function number 4 is the search function, where you pass a value. Let's say you want to search 51. You will pass 51 and then you will traverse throughout this tree. So this is 51. So you'll traverse throughout this tree and come to 51. And if you get a match, you will say you found it. If not, then you will say the value is not there. Okay. So this traversal needs to be done. That will happen in this search function. And then 5A and 5B are related to deletion of the node, which, as the function name represents or says, is going to delete a particular node. Now delete is going to be a little tricky. We will tackle that in the very last. And to delete that, we also need an extra function, minimum value node. We'll talk about this in detail. But yeah, this is how the overall class would look like. It's a little cluttered. There are a lot of things to do. But as I mentioned, we will tackle them one by one. So yeah, this was the overview that I wanted to give you in the form of implementation about the two different classes of the treenode class as well as the BST class, and the different functions, the standard binary search tree functions that we are going to do. These are the standard functions. We might add something extra later on depending upon the necessity or depending upon your request. So it might get updated. You'll have to see the entire course. But now let's move on to the programming part, and let's start off with setting some things up for the coding part, because in the next video, we will start off with writing the functions. So let's get the boilerplate ready. Let's get the structure of the C++ program ready. So let's move on to the Dev C++ IDE, and I highly recommend that you type along with me. Okay, so as you can see on the screen, I have my Dev C++ IDE open, and I've written a little bit of C++ code, basic structure. And the very first thing that we want to do is we want to create our own treenode class, right? So I'm gonna write class treenode. Inside that class, what do we have? We have 3 different data members. I'm gonna write all of them in the public access modifier. Again, I hope you know what is public private access modifier, the classes and objects concepts. If not, as I mentioned, I have a separate course on C++ programming. You can check it out. Check that playlist in the video description. But to give you a basic idea, everything in the public is directly accessible, and that makes life easier. We don't have to write extra getter and setter functions. Over here, I'm going to say int value. Then we have 2 pointers of the same treenode class. So I'm going to say treenode star left, and I'm going to say treenode space star right. So I did 2 different ways, and both of them mean the same thing. You can say treenode and then star, or treenode space and then star. Both of them actually mean the same. Okay, these are both pointers only. Sometimes I get questions about why are these 2 different. They're not different, they're the same thing. Alright, moving down, I'll also put up the treenode class on the right hand side. You can see the pseudocode. The next thing now we want the constructors default as well as the parameterized constructor. So I'm just gonna quickly create it over here. Okay, so there you go. This is the default constructor, and this is the parameterized constructor. Okay, you guys can pause the screen and type the code yourself. I highly recommend, as I mentioned, to type the code once at least. The parameterized constructor takes the integer value. So value is nothing but data or key. Remember, I already told you we are using the term value, but it is also called as key or data. We take v from the user and we set this v into this value. And of course, left and right for the first time when you create the node is gonna point to null. Okay, later on we will link them in the BST class or using the BST class functions. Okay, so this was the treenode class. The next thing that we want to do is we want to create the BST class, right? So let's write class BST. Inside this, of course, we have so many functions which we will do one by one later on. But in the public part, the one thing that we can create right now is a data member. We have only one data member, which is treenode star root. Okay. So after this, we have all the member functions. The first member function is empty, and we can create it right away in this tutorial itself. So we'll say bool is empty. And how do you check if the tree is empty? When I say empty, it means that there are no nodes linked in it. We simply say if root equal to null. So if this root pointer has the value of null, we can safely say return true, which means that it is empty. In the else part, we will say return false. If root is not null, which means root is pointing to some node object of type treenode, it would mean that we have some node linked, right? Even if we have one single value in the BST tree, which is the root value, it is still not empty. Which means that if there is some value inside this root node pointer, the tree is not going to be empty. Okay. Alright, so the remaining functions we will do in further tutorials step by step, and we will take one function at a time, one member method. It is also called as method. Okay, so when I say function, it is method. So methods and functions are pretty much the same thing, with the difference being that when you write a function inside a class, it is called as a method. Okay, so that's just the language that is used or the convention that is followed. But moving on, now let's get into the main function. So this is where the entire action happens, of course, in a C++ program. So our goal is to create a menu driven program. So a menu driven program is where on the command prompt, you will get a prompt, you will get multiple options for the different binary search tree operations. For example, you'll see a screen and you'll see different options, option number 1, 2, 3 and 4 and 5 and so on and so forth for the corresponding binary search tree operations. And it will be like select 1 for insertion, select 2 for printing, select 3 for deletion and so on and so forth. So that menu driven program will keep on running till you enter a particular value, let's say 0, and then you will exit the program. So that's the goal of our entire implementation, so that it becomes a little more dynamic and interactive. And we've done this kind of coding previously also for linked list and stack and queue and different implementations. So if you followed those tutorials, you know that we use a do while loop. So let's do the do while loop. I'll write do and then I'll say while. On top of that, we'll first have to create int option, which is the option number which user will enter. Okay, then we will say cout, what operation do you want to perform, and this has to actually go in the do while loop because it will keep on repeating. Of course, the opening and closing brackets of do while loop. Remember, you have to add a semicolon after the do while condition, and here the condition is while option is not equal to 0. Okay, so when the user enters 0, this do while loop will break and we will come outside. But till then, this do while loop will keep on running. And the reason why we're using a do while loop, I hope you guys know, is that for the first time, this loop has to run regardless. So we need to see the menu, right? So we don't want any condition to be checked in the first run. And that's where this exit controlled do while loop helps. So inside this, we'll say cout, what operation do you want to perform? Then I'm going to append one more thing. I'll say select option number and enter 0 to exit. Okay, so now let's print out the options. Okay, so these are the different options. I have copy pasted it from my existing code because I don't want to waste time. You guys can pause the screen and type it out. Especially if you're a beginner, please do it at least once. So the options are insert node. So when the user enters 1, we will do the insertion. And of course, we need to write the code for these individual operations that we will do later on. But you get the idea, right? For option 2, we will do the searching. For option 3, we will do the deletion. For option 4, we will do the printing, and we will print all the different ways in one single go. You can add more options for printing in order, printing post order, printing pre-order, and so on and so forth. Option 5 will clear the screen, that is clear the command prompt, and option 0 will exit the program. So how do you iterate to these different options? So once you present this menu on the command prompt to the user will enter some value, right? So and that value is the option number which we will take from the user. So I'm going to say cin option, right? And now we're going to use a switch case to go through this different options. So we will say switch. You can also use if else, but switch case is better suited for this. We will say option. So the first case is case 0. When I say case 0, it means when user enters 0. Of course, we will have to break the entire loop. So that's why we simply say break. we will come outside the switch case, we will come at the end, and the condition will be checked while option not equal to 0, but the option has been equal to 0. So we will come outside this do while loop also, right? After that we have case 1. Now case 1 is insert operation, and all the code for insertion will go over here. Insertion code, which we will do in later tutorials. Right now we are just creating the entire template, and then we have break. Similarly we have case 2, case 3, case 4, case 5. So let's copy this code and paste it multiple times. This is case 2. Case 2 is for search. Then we have case 3. Then we have case 4. Then we have case 5. And we also have a default case. So let's number this. This is case 4. This is case 5. And we will also have a default case. I hope you know what is a default case. Default is used in case user enters some random number which is not in the switch case. So we'll say enter proper option number. So for case 3, case 2 it is search. What is case 3 or number, option number 3? It is delete. So let's write delete. Case 4, what is option 4? It is printing. So I'll write print and traverse. Case 5 is nothing but clear screen. CLR SCR. There is a standard function which is basically this system, and in brackets you have to type CLS. This will completely clear the screen. So in fact this cout will also be cleared, so we don't need to type it. And yeah, that is pretty much our menu driven program right now. We will have to create the binary search tree object. So we will have to create BST object over here or somewhere over here, and then call these individual functions which are there inside this BST class. Of course, all the member functions, that is the member methods, can be accessed using the object of this BST class, right? So we will have to do something like BST obj. We'll have to create an object. Then later on we'll have to say obj.insert, obj.search, so on and so forth. But that is something that we'll do later on. Let's save this and let's see if this executes so far. I'll say compile and run. Okay, so far the program is running fine. You can see our menu driven program is showing up. It's saying what operation do you want to perform. Select option number 0 to exit. So if I say 0, the program will completely exit. You can see process exited. And now if I again compile and run it, let's enter option number 1, that is insert. When I say option number 1, hit enter. You can see insert is printed. And again the menu driven program is shown, because until and unless we type in 0, that do while loop will not stop. So now I can do search, option number 2, hit enter, you can see search. I can do option number 3, which is delete, hit enter, you can see delete is printed. I can do option number 4, which is print, and I get print and traverse. I can do 5, which is clear screen. If I hit enter, the entire screen is cleared, and again the entire menu driven program is printed again. So our menu driven program is working fine. We have pretty much typed in the entire structure of our code of our BST search tree program, and I've saved it as BTS, not BST. That's by mistake. That's kind of funny. But yeah, in the next tutorial now, we will tackle the individual functions, individual member functions, and the BST search tree operations. Okay, so I'm gonna wrap this video over here, otherwise it will get stretched and you'll get bored. But I hope so far you've got the idea about how we are gonna approach this binary search tree implementation using the dynamic node creation, how visually it is gonna look like, and the different classes that we've created over here. And if you've watched the linked list programs, if you've watched the other tutorials in this course, you'll understand everything much more easily. So I'm gonna wrap this video over here, and a quick note for you guys for the next tutorial. Make sure you understand what is recursive function, because recursion is gonna be used in some operations. I have a separate video on recursive function. I'll drop the link in the video description, just if you want to brush your knowledge, brush your concept up, and if you don't know, it is absolutely important. Okay, so if you like this video, please give it a thumbs up. That would be a huge help. Let me know in the comments how this video was. Since you've made it so far, drop your suggestions. If you liked it, let me know in the comments. I would definitely reply to you. Do share this video with your friends. It is very important. And like always, thanks for watching. See you in the next one. Peace.